So we are discussing greedy technique in this section. Let's try to understand what this approach is about. This is the simplest and most natural approach of solving the problems. Believe me, you will find it very natural to think about, and our brain most of the time uses this approach to solve the problem at first place. Very natural way of thinking. Formally, a greedy algorithm, as the name suggests, always makes the choice that seems to be the best at that moment. This means that it makes a locally optimal choice in the hope that this choice will lead to globally optimal solution. If I give you a few things to choose from a bag with price tags but absolutely free for you, what will you do? You might become greedy and choose the items with highest prices, right? But what about if I ask you to choose few items within a maximum capacity? You can start choosing the highest tag item first, as the human nature of being greedy. Here comes the optimality problem. How do you decide which choice is optimal? So let's define this formally again. Assume that you have an objective function that needs to be optimized, either maximized or minimized at a given point. A greedy algorithm makes greedy choices at each step to ensure that the objective function is optimized. The greedy algorithm has only one shot to complete the optimal solution so that it never goes back and reverses the decision. So if we take a pause and think, sometimes being greedy at each step may lose the overall optimality, because in greedy technique there is one shot and then you can't change the decisions. So greedy algorithms have some advantages and disadvantages. It is quite easy to come up with a greedy algorithm for a problem. Also, analyzing the runtime for greedy algorithms will generally be much easier than for other techniques. For example, divide and conquer. For the divide and conquer technique, it is not clear whether the technique is fast or slow. This is because at each level of recursion, the size of problem gets smaller and the number of subproblems increases. The difficult part is that for greedy algorithms, you have to work much harder to understand correctness issues. Even with the correct algorithm, it is hard to prove why it is correct. Proving that a greedy algorithm is correct is more of an art than a science. It involves a lot of creativity. So let's try understanding with this an example. This is called a coin change problem. Here you are having $1 coin, $2, $5, and $6 coin. You are asked to draw $11 from ATM machine where the logic runs on greedy. And you want the minimum bills. ATM machine, being greedy, tries to find the next local choice without being worried about global solution much. So first it chooses $6 bill, then $5 bill. It becomes $11. So the greedy approach works fine here. But what if the ATM machine is asked to withdraw $10? It first chooses $6. Now for next local choice, it can't choose $5 because it will exceed the requirement of $10. So it will go for $2 and $2 again. Whoops, this is not the optimal solution. Solution could be $5 plus $5, only 2 bills of $5, but our greedy algo solved it in 3 bills. Now you might be able to understand that how greedy can go wrong, but it can be very fast in terms of time complexity. Now to extend our discussion further, if we apply greedy, there are some problems. For example, fractional knapsack, load balancing, independent sets guarantees the optimal solution, but some problem struggles and fail to guarantee the optimal solutions. For example, these are 0-1 knapsack and coin change problem. However, coin change depends upon input currencies, but greedy cannot cover all the cases there. So hope you might got a decent idea about greedy approach. Let's discuss identifying and approaching the solution using greedy in upcoming lectures.